Welcome back. Isaac Newton was a towering figure in the history of science, renowned for his groundbreaking contribution to mathematics, physics, and astronomy. Born on January 4, 1643 in England, Newton's early life was marked by personal challenges, including the death of his father before he was born and a tumultuous relationship with his stepfather. Despite these difficulties, he displayed an extraordinary aptitude for learning and eventually enrolled at Trinity College, Cambridge in 1661. Newton's most significant work was conducting during a period known as Annus Mirabilis, Year of Wonders, from 1665 to 1666, when the plague forced him to retreat to his family estate. During this time, he developed the foundation of calculus, formulated the laws of motion, and investigated the nature of light and optics. His seminal work, Mathematical Principle of Nature Philosophy, published in 1687, laid down the three laws of motion that form the core of classical mechanics and introduced the law of universal gravitation, explaining how all objects in the universe attract each other with a force proportional to their masses and inversely proportional to the square of the distance between them. In addition to his work in physics, Newton made significant contributions to mathematics, inventing calculus independently of Gottfried Wilhelm Leibniz. He also conducted pioneering experiments in optics, demonstrating that white light is composed of a spectrum of colors, which he revealed by passing light through a prism. Newton's intellectual rigor and methodical approach to scientific inquiry helped lay the groundwork for the alignment and the subsequent advancement in science and technology. He died on March 31, 1727, leaving behind a legacy that continues to influence and inspire scientists and thinkers around the world. Newton's law of motion are fundamental principles that form the basis for classical mechanics, which is the branch of physics that deals with the motion of objects. Newton's first law, often called the law of inertia, states that an object will remain at rest or move in a straight line at a constant speed unless acted upon by an external force. This means that if no force is applied, an object's velocity will not change. For example, a book laying on a table will stay there unless someone pushes it, and a ball rolling on a frictionless surface will keep rolling forever at a constant speed. Newton's second law. The law of acceleration provides a quantitative description of the changes that a force can produce on the motion of an object. It states that the force acting on a object is equal to the mass of the object times its acceleration. This law explains how the velocity of an object changes when it is subject to an external force. For instance, if you push the shopping cart, it accelerates in the direction you push it, and the acceleration is proportional to the force applied and inversely proportional to the cart mass. Finally, Newton's third law, the law of action and reaction, states that for every action, there is an equal and opposite reaction. This means that forces always come in pairs. If you push against a wall, the wall pushes back with equal force in the opposite direction. This principle is observable in many everyday situations, such as when you jump off a boat and the boat moves in the opposite direction. Together, these three laws provide a comprehensive framework for understanding the motion of a sub-object and the forces that affect them, making them essential for the study of physics and engineering.